Hello students, good morning. Okay, welcome to my channel once again. Okay, I'm your Sofique sir. So in today's class we are going to discuss about certain important concepts. Okay, it may not be so important for NEET point of view, but it's going to be very much required for JEE and advanced, right? So for that I'm showing a circuit, this one. Okay, so definitely this is a Wheatstone bridge circuit. Am I correct? Okay, but this is an unbalanced Wheatstone bridge. 2 by 6 is not equal to 6 by 8, or 2 by 6 is not equal to this side also 6 by 8, same thing. Okay, fine. So this is an unbalanced Wheatstone bridge. So we cannot call exactly that these two are in parallel. No. Okay, this is in series with that one or this one. We are little confused. So whenever we get a circuit like this, how exactly we are going to solve it, right? So for that I'll be explaining you three different procedures, three different methods. Okay, so I'm taking this one as an example to explain those methods. So you have to learn the method and you can apply it in everywhere. Okay, so let us start. So the first method is charge distribution method. How can you solve this particular circuit? By charge distribution method. But let me remind you, this charge distribution method is a little lengthy, but this is applicable everywhere. For any circuit you can use it. Okay, so my advice, you'll be using it only in those situations when you cannot solve it by other method. Otherwise this method is going to be a little lengthy. Okay, so in charge distribution we will assume a battery to be connected between the two terminals A and B, and between these two A and B we have to find the equivalent capacitance. So let us assume there is a EMF of V volt, positive, negative. Okay, so we can give any value to this EMF. For example, let me assume it to be a 10 volt EMF. You can call 100 also, no problem. So what exactly we are going to solve it? For example, because of this particular circuit, from this capacitor a charge Q and goes and enters here. A charge Q enters here. So if a charge Q is entering from this side, how much charge will be coming out? Q. So altogether across this battery, how much charge is flowing? Q charge is flowing over a potential difference of V volt. Okay, so that means if we replace this entire circuit by a single all these capacitors by a single capacitor, okay, which will be called as the equivalent, then when it is connected across the same battery, then it should draw the same amount of charge from the battery. Okay, so this group we are going to replace by a single capacitor. Then how much will become C equivalent? C equivalent will become Q by V, that is Q by 10 in this case. So C equivalent is nothing but we have to get this expression Q by 10 from here. Okay, for that what we do, let us go for a charge distribution. For example, suppose a charge Q is coming from this side and a charge Q1 goes to this particular capacitor Q1. Then this side how much will go? Q minus Q1. So this is plus Q1, this side is minus Q1. And how much will come here? Q minus Q1. On this plate, how much charge will deposit? Q minus Q1. Okay, if Q1 charge enters, then Q1 charge will be going out. How much charge is entering here? Q minus Q1. Similarly, let me say the charge here is suppose going to be, or let me draw the diagrams like this. Let me say the charge entering in this capacitor is Q2. If Q2 is going, how much charge will be coming down? Q1 minus Q2. Q1 is coming, Q2 is going, so how much is coming down? Q1 minus Q2. Okay, plus Q1 minus Q1 plus Q2 minus Q2. If minus Q2 is on that side, how much is coming out? Plus Q2 is coming out from that side. Okay, here total charge will have to be how much? Q. Okay, see now. This is Q minus Q2. So here it will become minus Q plus Q2. Minus Q1 plus Q2. How much charge is entering here? Q1 minus Q2. So how much will be flowing out? Q1 minus Q2. is flowing out this way. Okay, so on this particular plate of the capacitor, this is positive, this is negative. What is the charge? Q minus Q1. So the other side on the negative plate, how much will become? On this side, let me show you, Q1 minus Q, negative of that. Okay, so this side how much is entering? Q1 minus Q2, because how much is entering here? How much is entering? Q1 minus Q2. So how much will be going out? Q1 minus Q2. This side how much is coming? Q minus Q1. So how much will be going out? Q minus Q1. Q minus Q1. So both will get added up. So how much charge will deposit on this particular plate? Plus Q1 minus Q1 will get cancels. Q minus Q2. So on this particular plate, charge is Q minus Q2. Then on the other plate, minus Q plus Q2. So how much charge is entering? Q minus Q2. So how much will be flowing out? Q minus Q2. This side is how much is coming? Q2. This side is Q minus Q2. So finally how much will get? Q charge is flowing out. This is the distribution of charge in a circuit. Okay, you draw the diagram properly so that you understand. So our target is Q by V or Q by 10. Okay, we are taking a value of 10 to make the problem simple. See. Okay, now how we can proceed from here? How can we solve it? This particular point is A, this particular point is B. Let me call this particular point is D and this particular point as E. Now see, at this point potential is 10 volt, that point potential is 0 volt. Here potential is, suppose let me call VD only, and here potential is VE. Okay, now see how will you solve. Method 1, first method, VAB is nothing but 10 volt between these 2 points. Potential drop is how much? 10 volt. So VAB, I can write it as VAD plus VBB. Yani potential difference between this point and this point is nothing but potential difference between the A and D plus potential difference between D and B. Clear? What is the potential difference between A and D? Is nothing but charge divided by capacitance. Okay, what is the capacitance? Let me show you once again. What is the capacitance? Suppose C1. What is your charge? Q1. This point is what? A. That point is what? D. So what is the potential? What is VAD? VA minus VD will become how much? That is VAD between A and D. Q1 by C1. Last class also, the first point I have explained this. Okay, so VAD is nothing but charge divided by capacitance. How much is that? Q1 divided by 2. Q1 divided by 2. And the second situation between D and B. What is the potential difference between D and B? It's nothing but charge divided by capacitance. Plus Q2 divided by 6. How much is that? 10. So from here you'll get 3Q1 plus Q2 is equal to 6 was the LCM, 60, equation number 1. Clear? Equation 1. Note it down. Similarly, again, I'll use the same equations again. Here, let me start from here. Again, VAB can be written as VAB. How many variables I have got? Q1, Q2, 3 variables I have got. Okay, fine. VAB, I can write it as VAE plus VEB. VAE plus VEB, which is equal to how much? 10 volt. What is VAE? Potential difference between these 2 points, charge divided by capacitance. Q minus Q1 divided by 6. And how much is that? VEB between E and B, charge divided by capacitance. That is Q minus Q2 divided by 8. This is nothing but 10. Okay. So I'll modify it. a little bit from here. 6 and 8. So LCM is how much? 24. 24, that is 6 4q minus 4q1, and this is 3q minus 3q2. 3q minus 3q2. This is equal to 10. So 4 3 7, 7q minus 4q1 minus 3q2, correct, is equal to 240. This is equation 2. Okay, so keep that in mind. Equation 1, this is equation 1. Okay. Let me write the equation 1 on this side. 3q1 plus q2 is equal to 60. This is equation 1. Let me rub it off. I have 3 unknowns here, so I'll be needing 3 equations minimum. Let me take another part. AD, DE, EB. This is the third part. Again, let me start. VAB is equal to VAD plus VDE plus VEB. That is again equal to 10 volt. AD, DE, EB. AD, DE, EB. Okay. What is VAD? We have already done VAD. Q1 by 2 microfarad. How much is AD? Sorry, this is DE. DE is nothing but Q1 minus Q2 divided by charge divided by capacitance. And this one we have already done once. Q1 by Q2 by 8. This is 10. So here LCM is going to be 8. So 4 Q1 twice Q1 twice Q2 plus Q minus Q2 is equal to 10. Simplification part, of course, you can do it by yourself. Okay. Still I am showing you 4q1, 2q1, 6q1 plus q minus 3q2 is equal to 80. Clear? We have three equations now. 3 equations, 3 unknowns. So from this 3 equation, we can get the value of q. So how much it becomes C equivalent? Q divided by 10 is C equivalent. We got our answer. Right? 3 equations we have got. This is equation 1. 3q1 plus q2 is equal to 60. Equation 1. This is equation 3. 6q1 plus q minus 3q2 is equal to equation 3. You do equation 1 multiplied by 3. Okay, equation 1 you multiply by 3, then add with equation 2. See how much you'll get. 3 3 is 9. Okay, then add with 2. 7q, 9q1 plus 4q1. 9q1 minus 4q1. So that is 5q1. And 3q2 minus 3q2 will get cancels. This is 180 plus 240. How much will get? 240, 350, 420. Okay. Again, equation 1 multiply by 3, but this time you add it with equation 3. 9q1, 6q1, 15q1. Clear? Then 3q2 cancel. Q, it will remain as q. 3q2 minus 3q2 will become 0. How much will get? 180 plus 80, 240. Am I correct? 180 plus 80. Sorry, 260. Very simple. Now this will be equation 4 and this will be equation 5. So I have shown you the detailed solutions. Okay, right, no problem. 4 multiplied by 3, 4 you multiply by 3, then from that you subtract equation 5. Okay, 4 multiply by 3, 3 7s are 21, 21 minus q is equal to 20q, 15q1 minus 15q1 is 0. This one multiplied by 3, how much will get? 1020, 0, 3 2s are 6, 3 4s are 12, minus 260. So you are left out with 20q is equal to 1000, q is equal to 50 microcoulomb. Therefore, C equivalent was what? Q divided by V, that is Q by 10, Q is 50, so this will turn out to be 5 microfarad. So this is the first method, it's little lengthy. Okay, now I'll be showing a second method, nodal point analysis. That point is A, this point is A, that point is B. Nodal point analysis. So in this particular one, we'll take the distribution of charge. Again, we'll connect it to a battery. V, let me call 10 volt. So this particular point will become 10 volt. This particular point will become 0 volt. Let me call this particular point potential is X, and this particular point potential is Y. Okay, so let me go for a distribution of charge. This is plus Q1 minus Q1 plus Q2. On this side, suppose minus Q2. Okay, a charge of plus Q3 goes there, minus Q3. Okay, plus Q4 minus Q4, and here plus Q5 minus Q5. Okay, so this way what goes out finally? Minus Q3 plus Q3 will be going out. This side how much will be going out? Minus Q5 plus Q5 will be going out. So the charge flowing out is nothing but Q, which is Q3 plus Q5. Similarly, how much is the charge entering here? Okay, Q is how much? How much charge is entering here? This side is Q1, this side is Q2. So charge entering is Q is equal to Q1 plus Q2. This is a charge entering. Okay, so if I have to find the equivalent of this, let us say this is the C equivalent. So we have seen a charge of Q is coming out, which is Q3 plus Q5, and a charge Q is entering, which is Q1 plus Q2. This is okay. So therefore C equivalent will become Q divided by V. Q divided by V. Okay, so Q divided by V, Q divided by Q is how much? You can write Q3 plus Q5 divided by V. If V is equal to 10 volt, then you can put here 10. Okay, but here what is Q3? If I call a potential here to be X and here 0, so potential difference across this one is how much? X. So that means I can call Q3 to be charged in the capacitor is nothing but capacitance into potential difference. What is the capacitance? 6. What is the potential difference? X minus 0, that is X. Similarly, Q5 is how much? What is the potential here? Y. I have assumed to be Y. What is the potential here? 0. So potential difference is Y. So charge is nothing but capacitance into potential difference, that is 8Y. Okay, so basically what we are looking for C equivalent is nothing but 6x plus 8y, 6x plus 8y divided by V means 10. We are basically looking for these particular expressions. So from this particular circuit, somehow you have to get a value of x and y. Okay, इसको हम करते हैं, आया समझ में? चलो, let me rub it off, let me go and make the equations. अभी उसके लिए हम लोग क्या यूज करेंगे? नोडल पॉइंट एनालिसिस. दिस इज नथिंग बट किरचॉफ्स जंक्शन रूल. we'll be talking about that in detail in current electricity. You see, this one will be called a nodal point. You see, with this point, three plates of these three capacitors are connected. 1, 2, 3. And these three plates are basically isolated plates. In the last class also I have spoken about it. Okay, these three plates, okay, they are not having any external connection. Battery is not connected to them. इन दोनों के बीच में क्या है? Air is there, otherwise there will be dielectric which will be insulator. Between these two, air is there or there will be dielectric at most. हम लोग इस situation में तो air है, okay. So basically plate 1, plate 2 and plate 3 isolated. Similarly, to this particular point, these three plates are joined. This one and this one. This is another three plates which are again isolated, having no connection with battery. This plate is connected to the battery. देख लो, ये प्लेट बैटरी के साथ कनेक्टेड है, देख लो, ये बैटरी के साथ कनेक्टेड है, लेकिन ये बैटरी के साथ कनेक्टेड नहीं है. इन दोनों के बीच में गैप है, एयर गैप. So there is a gap in between these two. This is not connected to a battery. So these three plates also again going to be isolated plates. So the total charge on these three plates will have to be 0. Okay, क्योंकि यहाँ चार्ज आ नहीं सकता. जो भी चार्ज यहाँ पर प्रोड्यूस होगा वो by the process of induction होगा, इसीलिए नेट चार्ज, induced charge will become 0. इसमें भी. So इसीलिए from this nodal point we can write the sum of these three charges equal to 0. That means we can write from this about this point x, we can write minus q1 plus q3 plus q4 is equal to 0. Okay, let us see how much is q1 minus q1. Okay, अगर ये कैपेसिटर है, this particular point is 1, this particular point is 2, इसमें है चार्ज प्लस q एंड इसमें है चार्ज माइनस q, कैपेसिटेंस है c. इस पॉइंट का पोटेंशियल है v1, इस पॉइंट का पोटेंशियल है v2. अब ये qc और v1 v2 के बीच में रिलेशन क्या होगा? हम ये से लिखेंगे v1 माइनस v2, v1 माइनस v2 into charge into capacitance is equal to charge plus q. यानी we can write q is equal to c into v1 minus v2. अभी q की जगह में अगर मुझे माइनस q लिखना है तो मैं क्या करूंगा? इसको जस्ट उल्टा कर दूंगा, that's all, v2 minus v1. ओके, सो ये पॉइंट और इस पार्टिकुलर पार्ट को अगर मैं यहां पर कंसीडर करूं, अभी इस पार्ट को मैं कंसीडर करता हूं. पॉइंट A which is 10 वोल्ट, इसमें है you have the charge q1, capacitance is suppose you 2 microfarad, and this particular potential I have called it as x plus q1 minus q1. So कैसे लिखूंगा इसको? How much is q1? q1 is nothing but capacitance multiplied by potential difference. How much is that? 10 minus x. अगर इसी को मुझे minus q1 लिखना है तो मैं कैसे लिखूंगा? 10x minus 2x minus 10. So इसीलिए in place of minus q1 I'll write 2x minus 10. I hope you will follow it like this. Clear? Okay, तो ये पॉइंट ये प्लेट लिया तो दिस पोटेंशियल माइनस दैट पोटेंशियल, दिस पोटेंशियल माइनस दैट पोटेंशियल डिवाइडेड बाय कैपेसिटेंस. ये प्लेट लिया, दिस पोटेंशियल माइनस दैट पोटेंशियल. q3 I have already shown you how much is q3. q3 is how much? 6x. Okay, capacitance is 6. Potential difference between this point and this point is what? X minus 0, that is x. Similarly q4 this particular plate, so this potential minus that potential. Okay, so how will you write it? Capacitance multiplied by potential difference, x minus y. This should become equal to 0. So here we'll get an equation between x and y. Twice x minus 20, 6x 4x minus 4y is equal to 0. So that is why twice x 6x, this is 12x minus 4y is equal to 20. 20. So 3x minus y is equal to 5. Divide by 4. 4 3 is 12, 4 1 is 4, 4 5 is 20. So we'll call it as equation 1. You have understood? Equation 1. Similarly, we'll go to the second point. In the second point, we'll write minus q2 minus q4 plus q5 is equal to 0 across this particular point. Minus q2 minus q4 plus q5 is equal to 0. See, minus q2 कैसे लिखेंगे? Minus q2. जिस तरह से minus q1 लिखा था, minus q2. This particular plate. These three plates are again isolated plates. Minus q2. Plate is on this side, so this potential minus that potential multiplied by capacitance. 6 into y minus 10. Minus q4. Minus q4, this potential minus that potential divided by multiplied by capacitance. 4, what is that? Y minus x. Similarly, q5, this particular plate, so this potential minus that potential. So q5 is what? 8 into y minus 0. q5 is what? 8 into y minus 0, 8y. This one I have already done. Okay, so C equivalent. So इसको simplify करते हैं, कितना मिलेगा? Let us do it quickly. Okay, समझ में आ रहा है क्या नहीं आ रहा है? 6y plus 4y minus 4x plus 8y is equal to 0. So how much will be getting? Minus 4x. Okay, no problem. Minus 4x, 10, 18, y is equal to 60. So 9y minus twice x is equal to 3, yeah, is equal to 30. Equation 2. So now we need to solve these two equations. So these are the two equations you have got. When you solve these two equations, you'll find x to be equal to, you multiply by 3, this one you multiply by 2. Let me finish it off. 2 multiply by 3 plus 1, equation 1 multiplied by 2, equation 2 multiplied by 3 implies. करो, करके देखो कितना मिलेगा. This one you are multiplying by 2. 6x. This one you are multiplying by 3. 6x. One is minus, the other is plus. So your x and x will get cancels out. Okay. This one you are getting multiplied by 2. So this is minus twice y. This one you are multiplying by 3. 9 3s are 27. Okay. 5 3s are 15. Sorry. This is multiplied by 2. This is 10. And this is multiplied by 3, 90. How much are you getting? 100. So this is 25. So y is going to be equal to 4. Okay. Since y is equal to 4, therefore equation 1 implies 3x is equal to what? 9. 4 plus 5 is 9. So how much you have got? X is equal to? X is equal to 3. So you got a value of y and you got a value of x. So how much will be getting? Therefore C equivalent is equal to, what is C equivalent? 6x plus 8y divided by 10. 6 3 is 18. 8 4 is 32. Okay, 50 divided by 10, how much is that? 5 microfarad. Got the same answer? Okay. Okay, so let us go for the third method now. Method 3. इस method 3 में हम लोग क्या करेंगे? What exactly we'll be doing in method 3? If a circuit is like this, it will be called as delta. Okay. Suppose एक particular सर्किट का एक particular part है, the part of a circuit network. So here you can see three resistances are connected and they are forming the shape of a triangle. Okay, we'll call like this. This particular circuit can be converted to this circuit. It's like the letter Y, so it is called delta Y conversion or Y delta. Okay, इस सर्किट को इस सर्किट में कन्वर्ट कर सकते हैं by with the help of some relations. इसका derivation तुम्हारे लिए जरूरी बिल्कुल नहीं है. ओके, तुम्हें सिर्फ रिलेशन याद रखना है. Similarly, अगर if a circuit is there in the form of Y, it can be converted to this particular circuit. इसके लिए कुछ रिलेशंस है, इससे याद रखना पड़ेगा. ओके, इस रिलेशन को याद रखना पड़ेगा. ओके, और इसको याद रखना इतना मुश्किल नहीं है, बिल्कुल आसान है, थोड़ा प्रैक्टिस का जरूरत पड़ेगा. देखो कैसे याद करोगे. अगर ये पार्टिकुलर सर्किट है, बेसिकली आई विल बी शोइंग इट फर्स्ट फॉर रेजिस्टर्स. जब हम इसको रेजिस्टर के सीख लेंगे, वी विल एबल टू इजीली कन्वर्ट इट फॉर कैपेसिटर्स. When the circuit is like this, you check carefully between A, B and C. यानी ये सर्किट है, इस सर्किट को हमें रिप्लेस करना है by 3 different resistors. यानी इस पार्टिकुलर डेल्टा सर्किट को हमें कन्वर्ट करना है इस पार्टिकुलर फॉर्म में. ओके, ये पार्टिकुलर फॉर्म में, ये RA, ये RB एंड ये RC. लाइक दिस वी हैव टू मेक इट. ठीक है, तो अच्छी तरह से ध्यान दे के देखो. अब अच्छी तरह से देखोगे तो ये जो RA है ना, RA है, इट इज बिटवीन 1 and 2. RB इट इज बिटवीन 2 and 3 and RC is between 3 and 1. अब डेल्टा टू Y या डेल्टा टू Y कन्वर्जन आप कैसे याद रखोगे. जैसे मैंने RA निकालना था, तो RA was between R1 and R2. so न्यूमरेटर में क्या आ गया, R1 into R2 divided by R1 plus R2 plus R3. अब बताओ RB is between 2 and 3, कितना होगा, R2 into R3 divided by R1 plus R2 plus R3. Similarly, R3 is between what, 1 and 3, so we'll be writing R1 R3 divided by R1 plus R2 plus R3. Okay, so in all these situations the denominator is same, simply numerator will be replacing by 2 resistors. Okay, on 2 sides of it. Similarly, अगर ये Y है, इसको हमें डेल्टा में कन्वर्ट करना है. Okay, पहले ये दिमाग में डाल लो कि it is easy. First you think this is easy, then you practice it 5-6 times. Okay, it will become, I don't think there will be a problem in remembering it. अब इसको कन्वर्ट करते हो कैसे याद रखेंगे हम लोग. A की जगह में, A B C की जगह में हमें 1 2 3 लाना है. तो इसका न्यूमरेटर में RA RB RB RC RC RA डिवाइडेड बाय RB. अब देखो 1 is against B, 1 is against B, so B का साथ कौन सा रेजिस्टर्स एसोसिएटेड है, RB, इसीलिए डिवाइडेड बाय RB. यानी मैं अगर R2 लिखूंगा, न्यूमरेटर सेम होगा, R2 लिखूंगा, न्यूमरेटर सेम, RA RB प्लस RB RC प्लस RC RA. डिनोमिनेटर में कौन आएगा, the point which is against R2 is C का साथ कौन सा रेजिस्टर्स है, RC, तो इसमें कौन आएगा, सिर्फ RC. और R3 न्यूमरेटर सेम, RA RB RB RC RC RA. 3 की अगेंस्ट में कौन है, A है, A का साथ कौन सा रेजिस्टर्स है, RA. तो इस तरीके से इसको याद रख सकते हो, इन टर्म्स ऑफ रेजिस्टर्स. अब जब रेजिस्टर्स के लिए याद रख लोगे तो हाउ विल यू डू इट फॉर कैपेसिटर्स. जैसे मुझे इसको कन्वर्ट करना है, देयर आर 3 कैपेसिटर्स फॉर एग्जांपल बिटवीन A B and C. A B and C, मैं इसको कहूंगा, ये C1 था, C1 C2 C3, so I have to replace by 3 capacitors, CA, this one I'll call CB, and this one I'll call CC. अब इक्वेशन कैसे लिखेंगे, ये जो रिलेशन है ना इसको जस्ट 1 बाय बनाएंगे सबको, 1 बाय सी ए, 1 बाय C1, 1 by C2, R1, R2, R3. So we'll be writing 1 by C1, 1 by C2, 1 by C3. This is 1 by for capacitors. Okay, this is में लिखेंगे 1 by CB. देखने में मुश्किल है लेकिन ये बिल्कुल सिंपल है। R2, R3 में लिखूंगा C2, C3, फिर 1 by C1, 1 by C2, 1 by C3. Similarly, in this situation 1 by CC is equal to 1 by C1, C3, 1 by C1, 1 by C2, 1 by C3. Even in calculation also it will not take much time. Similarly, अगर 3 capacitors are like this and a form of Y, अगर 3 कैपेसिटर इस तरीके से हैं, this is CA, CB and CC, we have to convert this Y in the form of delta. We want to convert it in the form of delta. Okay, C1, C2 and C3. Then we'll be getting, instead of R1 we'll be writing 1 by C1 will become equal to, okay, RA, RB, so we'll be writing 1 by CA, CB, 1 by CB, CC, 1 by CC, CA. This B will be writing 1 by CB. Okay, similarly this is 1 by C2 is equal to 1 by CA, CB plus 1 by CB, CC plus 1 by CCCA divided by 1 by RC will be getting 1 by C. Similarly, we'll be getting C3 from here. Okay. Now check out the problem, how we can solve it now. See, the circuit was like, see, this is Y, 3 capacitors, ABC. Okay, or you can check from below also, from this side also, this is Y. You have to touch any one. Yani this particular circuit, we want it to convert it to this form. This Y, we want to replace it by delta. Let me call this is A, this point is already B. Let me call this point is C. That means A, B, C. In between A, B, C, I have to call this is CA, this is CB, and this is CC. It is to be replaced by C1, C2, C3. How exactly it will look like? Okay, how exactly it will look like? Delta, this is Y. Okay, it's not looking like Y or what? इसको थोड़ा दिखा देते हैं. चलो, अब देखने में Y जैसा हो गया. Cause, चलो, ये देखने में Y जैसा हो गया. Clear? अब इस Y को हम डेल्टा में कन्वर्ट कर रहे हैं. यानी between A, B, C, this point is A means this point is A, that point is B means this point is B. A, B, C. इसको कन्वर्ट करना है. बाकी ये दोनों अपना जगह पर रहेगा. We are not touching these two. Only thing, these three are replacing by these three. Means यहाँ पर एक आएगा कैपेसिटर, यहाँ पर एक कैपेसिटर आएगा, यहाँ पर एक कैपेसिटर आएगा. इसको हम कहेंगे CA, इसको कहेंगे CB और इसको कहेंगे CC. यानी this circuit we have to convert into this form. इसको हमें इस फॉर्म में कन्वर्ट करना है. अगर इस फॉर्म में कन्वर्ट करोगे तो इट इज वेरी सिंपल. दिस टू आर इन पैरेलल. देखिए इसको तुम वहां कनेक्ट करो और यहाँ कनेक्ट करो, एक ही बात है, पैरेलल. ओके, दिस टू टर्न आउट टू बी पैरेलल, 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 इन सीरीज, अगेन इन पैरेलल दैट. सो वी कैन सॉल्व इट इजीली. ओके, सो इसमें से वी हैव टू टेक द ट्रबल ऑफ फाइंडिंग द वैल्यू ऑफ CA, CB, CC. ओके, no, not CA, CB, CC. This one we call CA, CB, CC. This one C1, C2, C3. Sorry. Okay, so this was in the form of y. Now we have to convert it into delta. Okay, so here we have to get the value of C1, C2, C3. We are converting y to delta, so we'll be using this group of relations. We have to get a value of C1, we have to get a value of C2, we have to get a value of C3. Clear? We'll be using this group of relations. Okay, so our circuit was like this was 2 microfarad, that was 6 microfarad, and this was 4 microfarad. This side was 6, that side was 8. Okay, this one we have to convert it to this form. From this y, we have to get this delta. But it's 6 and 8 in their respective place. We are not touching them, disturbing them. Only these 3 points, okay, we are modifying to this form. Okay, this is C1, C2. Sorry, this one is C2. This was C1. This is C3. Okay, so we'll be using, how much was C1? Let me do it. 1 by C1 is what? This one will be calling as CA, this one will be calling as CB, this one will call it as CC. CA CB, CB CC, CC CA. 1 by CAB plus 1 by CBC plus 1 by CCCA. That means product of these two, reciprocal of that. 2 6i 12, we'll be writing 1 by 12. 6 4i 24, we'll be writing 1 by 24. 4 2i 8, we'll be writing 1 by 8 divided by, okay, against C1, what point is there? Against C1, what point is there? B is there. Against C1, what point is there? CB is there. So this particular point, the capacitor connected to B, the capacitor connected to B is what? This is B. This is a capacitor connected to B is what? 6. So we'll be writing it as 1 by 6. So this will become 1 here. LCM will become 24. 24 means 2 plus 1 plus 3. 2 plus 1. Okay. Is it correct? Yeah. 3 plus 3 will become 6. So this will become 4, 3, 4, 3, 2. Therefore, C1 is equal to 2 by 3 microfarad. Similarly, we'll try to get 1 by C2. 1 by C2 is how much? Now you don't have to calculate again. You can directly write how much? 6 by 24 multiplied by C2. Which is C2? C2. Again C2, what point is there? This point you have call it a C. Again C2, this particular point. Again C2, what capacitor? CC. CC means the one connected to C. The one connected to C. So we'll be writing here 1 by 4. 1 by CC. So 1 by 4. So this will give you how much? 1 microfarad. So C2 is nothing but 1 microfarad. Similarly, the last one, 1 by C3. Okay. So denominator, the numerator part is 6 by 24. C3, this is C3. Opposite to it, the capacitor which is connected to this particular point. How much is that? 2. So I'll be writing 1 by 2. 12. So this is half. So C3 is nothing but 2 microfarad. C3, this is 2 microfarad. This is 1 microfarad. And this is how much? 2 by 3. Clear? Now, so you will get the equivalent of this. Now, these two are connected in parallel. Okay, if you have still confusion, let me show you one more step. On the top, there is only one capacitor. How much is that? 1 microfarad. These two are connected in parallel. These two are connected in parallel. They connected in this point and this point. So they are in parallel. Or you can call this one, instead of connecting it here, you can connect it there. So they are in parallel. So you can add them. 2 by 3 plus 6. How much will it become? 3. 18 plus 2. 20. So this side will come in 20 by 3 microfarad. Again, these two are in parallel. Right? Instead of connecting it, connected it there. 2 and 8 are in parallel. 2 plus 8, how much? 10. 10 microfarad. Now they are in series. What will be the equivalent of these two? 20 by 3 into 10 divided by 20 by 3 plus 10. 3 LCM, 30 plus 20, 50 by 3. 3 will get cancels out, and that is 200. How much are you getting? 4. So instead of these two, you have got an equivalent of 4. How much? 4. And 4 and 1 are in parallel. Equivalent is 5. So finally, you have got C equivalent is nothing but 5 microfarad. Understood? So let me come to one more problem. The last problem that we have discussed, there was no symmetry at all. Say 2, 6, 6, 8, 4. Okay, it was not like 2, 6, 6, 2. No, it's not like that. It was 2, 6, 6, 8, 4. So in no respect there was some symmetry in the circuit. But the problem considered now, it has a little bit of symmetry in between 2 and 2. This is 1, this is 1, this is 3, that is 3. So if we connect, if we allow a charge Q to enter, and if the charge get distributed like this, Q1, Q2, Q3, then the charge which will be coming out will become Q3, Q2, Q1. 1, 1, 3, 3, 2, 2. Okay, the charge which will go to Q1, same charge will have to come out from Q1. The charge which was going to Q3, same charge will have to come out from Q3. Okay, the charge which was going to Q2, same charge will come out from Q2. Okay, regarding this, I have solved, I have given a particular lectures on that symmetric problem, how to solve it. Okay, you can refer to my that lectures. So at least this kind of symmetry is there, right? ये समझने की बात है सिर्फ, very simple. So इसमें से एक certain amount of charge will come this way, no issues. But one thing is sure, यहाँ पर एक बात देखो अच्छी तरह से. The charge which was entering 2 microcoulomb, this side is coming out how much? 2 micro. Sorry, what is the charge entering here? Q2. What is the charge coming out here? Q2. Okay. एक बात ध्यान के साथ देखो, इसमें जितना चार्ज एंटर हो रहा है उतना ही चार्ज यहां पर जा रहा है, यानी द चार्ज व्हिच इज एंटरिंग Q दिस पर्टिकुलर 2 microfarad, सेम चार्ज इज गोइंग देयर. यानी इस पर्टिकुलर पाथ से neither charge is going up, neither charge is going down. Yani whatever charge is coming directly going to the other side, as if इसमें कोई connection है ही नहीं, as if. यानी इस connection को अगर मैं, if I break this connection, if I assume they are not connected, Q2 is coming, Q2 is going. Have you seen any difference in the distribution of charge? No. So I can assume these particular junctions to be a false junction, जहां पर distribution of charge is not taking place. Okay? अगर ये है तो मैं काम कर सकता हूं, ये दोनों कैपेसिटर को मैं लेके बाहर लेके आ सकता हूं. I can bring them out. If I bring them out, how the circuit will look like? Let me bring them out. यानी from A This is 2 microfarad, and that is 2 microfarad. And rest, everything will remain inside in their respective places. 1, 3, 4, 3, 1, 4. Okay. So now 4 and 4 in series equivalent will become how much? 2. So these two we can replace by a single capacitor. Microfarad. Okay, now you can solve the problem easily. How to solve the problem? For us, this is also y, or this is also y. At least one we can replace it because both are identical. Okay, 3 1 2, or this side is 3 1 2. Okay, so I'll be replacing it like this. Let the top 2 and 2 in series equivalent is 1. Let me call that is 1 microfarad. Below this to capacitor, let me keep it as it is. 1 and 3. Now this is y between these 3 points. This is y. This y I'm going to replace it by delta. That means I'm going to replace it by delta. Here one capacitor, here another capacitor, and here a third capacitor. I'm going to replace it by like this. From here to here one capacitor, that side one capacitor, and from here to here this is the other capacitor. Okay, now these two will become in parallel, they are two in parallel, they will be in series, all will be in parallel. We can solve it. Clear? So this particular part I am leaving for your homework. So इससे आगे तुम करो, खुद निकालो कितना होगा. You can call anyone C1, anyone C2, anyone C3. You try it. Okay. And you get the answer. इसमें answer कितना आ जाएगा? I have the answer. I'll give it to you. It's 11/4 microfarad. Okay. इसको try करके देखो, निकल जाएगा. Let me discuss one more point. This particular circuit. This is also very common question. Basically, they ask. इसका capacitance कैसे निकालेंगे? इसमें at least some symmetry is there. C1, C1, C2, C2. In between there is C. Okay. So this one also you can connect it with a battery. Okay, like the way I have done nodal point analysis. Is particular point charge distribution ले लो, plus Q1 minus Q1, plus Q2 minus Q2, plus Q3 minus Q3, plus Q4 minus Q4. इसको 4 ले लो, इसको 5 ले लो. Okay, plus Q4 minus Q4. फिर okay, this is the sum of these three charges. Minus Q1 plus Q2 plus Q4 will become equal to 0. Take the potential, this point to be 10 volt. This is 0 volt. Assume it to be 10 volt. This point potential is X. This point potential is Y. Then Q1 you replace it. Minus Q1 you replace it by how much? X minus 10 into C1. X minus 10 into C1. And Q2 you replace it by C2 into X. And Q4 you replace it by C3, the potential difference X minus Y. Okay, so from here we'll be getting one equations. Similarly, around point Y, the sum of these three, minus Q3 minus Q4 plus Q5 will become 0. Okay, so get the value of X and Y. Get the value of X and Y. How much is coming from this side? Q2. How much is coming from this side? Q5. So C equivalent will become how much? Q2 plus Q5 divided by 10 volt. Okay, V. This is C equivalent. Okay. Refer to the nodal point analysis concept. So Q2 will become C2 into X. Q5 will become C1 into Y divided by 10. So ये दोनों equations से तुम्हें X और Y का वैल्यू निकालना है. Finally, you have to do it. So इस तरह से करोगे तो you'll be getting an equation. I am giving the relations. C equivalent. Finally, how much will be getting? C equivalent. Finally, you will get it all. C1, C3, C1, C3. Let me put the circuit again. C1, C2, C3, C2, C1. C1, C3 plus C2, C3 plus twice C1, C2 divided by C1 plus C2 plus twice C3. C1, C3, C2, C3 plus twice C1, C2 divided by C1 plus C2 plus twice C3 equivalent. अगर इस रिलेशन को याद रख लोगे तो इस टाइप का जितना प्रॉब्लम है, इस टाइप का जितना प्रॉब्लम है, लेट मी शो द एग्जांपल ऑफ दिस वन. दिस इज अ वेरी कॉमन क्वेश्चन दे कीप्स ऑन आस्किंग. C twice C, twice C, C and C. Okay, you can get this answer very easily. Let me show you quickly. How much will get now? This is 2C, this is C. C, C, twice C, twice C. बीच में कितना है? Twice C. So C equivalent कितना होगा? If you remember the relation, C1, C3, C1, C3, 2C square. C2, C3, 4C square plus 2 into C1, C2, 2C square divided by C1, C2 plus twice of C3. So 4, 6, 7, 4, 4, 8, 10. 10C square, 1C cancels out. So how much will be left out with? 10C by 7. Very easily you can get the answer. Okay. Check another one. Check another one. Two, 4 microfarad. Okay. 4 microfarad, 2 microfarad. In between, let us put 6 microfarad. Let us calculate what will be the equivalent. C equivalent. C1, C2, sorry, C1, C3, 12. C2, C3, 24 plus double of C1, C2, 8. Double of 8 is what? 16. Divided by C1 plus C2 plus twice of C3. इसका डबल कितना होगा? 12. 12 plus 6, 18. Clear? 12 plus 6 कितना है? 18. So कितना आएगा? 36, 42, 52 divided by 18. Okay, so finally we're getting 26 by 9 microfarad. So let us verify it with one more question. A and B. In between, let us call 4 microfarad. Okay, so let us try this one again. How much will become C equivalent? C1, C3, C1, C3, 4 ones are 4, C2, C3, 12, twice C1, C2. How much will become? 6 divided by C1 plus C2 plus twice C3. Okay, 9, 12, and that is 10, 22. So you will be left out with 11 by 6 microfarad. Okay. So students, I hope you have understood what has been discussed so far. अगर कुछ doubts है तो definitely you ask me in the comment section, or if you need any lectures on any of the topics, any of the portions from capacitors, you do let me know in the comment sections. Okay, so this question now I'm leaving for you as your homework. You try to solve it. You can solve it through charge distribution system also. Okay, or you can see there is a delta, you can convert it into y, or you can see there is a delta, you can convert it into y. Okay, whichever method you like, you try to get the answers of this particular question. The answer of these questions will become 11C by 15. Okay, so hope to see you in the next class. Goodbye.